Welcome to a read along with Dr. Powell in the book Discrete Perspectives in Mathematics. And this is section 2.1, beginning of the section 2.1. And we're going to be looking at power set merges. What does that mean? Well, a merge, at least in the sense that we're going to be talking about, have been talking about in this textbook, is a surjective function from a set to a subset of itself. In other words, it's kind of like you're just kind of chunking or blocking up pieces of your domain set, or merging elements together and relabeling with the name of maybe something in that set, perhaps. So we're going to be looking at power set merges that preserve certain types of structure. Why are we doing this? Well, logic, the study of logic and propositions can be modeled with power sets. And the types of functions and structure preserving merges that we do will say a lot about what we can do logically between logical statements and propositions. Okay, so let's get going with this. In this section, we're going to use this double arrow here to instead of this subset symbol. So A is a subset of B. We'll write this, and this will help us as we go forward and start looking at logic a little bit. In some sense, you could say if the truth is in A, then the truth is in B. And because this symbol is often used to mean implication, like this implies that. Well, and it makes sense. If you have an element in A, then that element is also definitely in B. So if the truth is in A, then the truth is definitely in B. Kind of intuitively, you can think of it that way. All right, so let's think about this symbol, this subset symbol, which we're going to be using as an arrow. All right, and some properties and different ways of looking at it. First, we're going to look at it as an existence property. How so? Well, let's look at a diagram here that shows different subsets of 1, 2, 3. It doesn't have the empty set here, but we have the other sets at least. So we're looking at a few of the subsets of 1, 2, 3, and we draw the symbol. So we don't have all the subsets, so we just have a few of them. Yeah, we're missing a few more, aren't we? Yep. But we have some of them, and we have all the arrow relationships where these arrow relationships mean is a subset of, that are drawn between the subsets that we're considering. Notice that something is a subset of itself, for instance. Okay, but also realize that this arrow can only be drawn, between certain things, but not between everything. Like 1, 2, 3 is not a subset of 1. So the question is asked, is this an operation? Is this symbol an operation? I mean, how we've been talking about preserving operations, functions preserving kind of an operation structure. So is it an operation? Well, usually for most operations, you can write, like, for instance, addition between integers. You can write an integer and then the symbol and then another integer, and you can always do that between any two integers. You can add them. Well, unfortunately, in this case, look, we can write this subset, the singleton set of 1, is a subset of 1, 2, 3, but we can't write the reverse. We can't write this, right? But in addition, you can always write the symbol between things, but here you can't even write it between these two things. So, in that sense, it's not really like a binary operation or an operation you can do between two things. However, you can kind of doctor it up a little bit, and so maybe that's what we'll do here. If we think about this, this as a binary operation, perhaps, where it has two outputs. So thinking of it as a function, all right, we're inputting something in here, and we're outputting exists and does not exist. And then the way we represent this operation is we can write this down when the image exists, okay, between the pair. So the pair maps to exist. When the pair maps to don't exist, guess what? You just don't write it. It's kind of a funny way of looking at it, but I guess if you look at it that way, I suppose it could be a binary operation. Um, but but it may not usually be termed as such. However, what we're going to be doing is we're going to be looking at functions that preserve a fiber, just one fiber of this binary operation. The fiber over the image exists, meaning if there's a relationship before the merge, okay, so if this relationship exists before the merge, then there is one afterwards. And we'll see some examples of that on the pages that follow. So if A implies B before, then F of A will imply F of B, or F of A will be like a subset in some sense of F of B with the transferred operation or transferred existence property, or however you want to say it, of this. Existence meaning, does there exist the relationship of subset between the two sets or not, in one direction. But functions not only just preserve operations, but they can preserve such existence properties or presence of a relationship between two elements of set. Okay, so we're only going to be focusing on one fiber of this, if we thought of this as a binary operation, but just one fiber being transferred, and that's the existence one. We don't not really concern ourselves with the other one being transferred. Okay, so let's take a look, for instance, at an example. So this subset is a subset of this one, so is a subset of that. Okay, so this arrow, so that means we can draw an arrow relationship between them. So if we're thinking about our binary operation, say, then this maps to exists, right? Because it exists, there's an existence between this relationship of subset exists between these two sets. And we want to transfer that to the codomain of the merge, which could be represented just by chunking, right? We're just chunking up the domain, and that the chunks are the images in the merge. And we want, so between these two chunks, if we have a relationship between these two guys, then there should also be a relationship between the two chunks that we made. It's kind of interesting because there could be lots of different relationships here, like before the chunking process, and each one of them will cause or could create a new or different relationship than you would see before amongst the chunks. So if there's a relationship between these two, and maybe between a couple more, I mean, as they are chunked up, you're going to see more happening. And we'll see some examples of that as we go. All right, here's just an alternate notation. All right, you can use the chunking, or you could just say the image of one image with using F right here. And you could say, okay, if you have this 1 arrow 1 3 before, then you also have, then it becomes, well, there's a existence over here in the image. Okay, and it's kind of a new kind of existence, but it comes from the other one. It's like the image of it, and it's defined as working as long as there are elements in the chunks, or in the pre-images rather, that have such an arrow. So existence relation goes to a transferred existence relationship in the image of the merge. Okay, there's just a little description here: ordered pairs for which this exists in power set cross power set, and that's the domain of the binary relation. And this is just the fiber over exists. Okay, so that's what we're looking at. There's at that. So and this goes from that fiber to that fiber, right? Ordered pairs for which this exists, and ordered pairs of images. So if there's an ordered pair between these guys before, then there will be an ordered pair between the images. So we're going to be looking at, so all we're building up to is we haven't looked at examples of functions like this, but this is the setup. We're going to be looking at functions that have this property. Okay, so we're going to be looking at some examples of this as we go along. All right. Any existence property can be transferred by a merge. Property exists before, property exists after merge, kind of with the basic setup that we've given. So here's our example, or first example here. Suppose we have this structure. All right. This is a structure of arrows and objects. The objects are subsets, and the arrows are just, you could say, arrows or existence properties, or the existence of a relationship one way between two things. All right. Now, what we're going to do is we're going to merge these two guys together. Let's merge this object with that object, and like this. Now, this will just merge with itself, nothing special in that, but we're just going to use these bars as representing the chunking, what happens after this merge. Okay, so notice that this arrow right here and this arrow all merge into the same arrow here. So you have an arrow from here to here, right? You have an arrow from here to here. So that in the merge, these two guys are the same all of a sudden, right? And so those arrows merge together. Notice that we have an arrow from here to here before, and we have an arrow from here to here. Now, where does this arrow from here to here go to? It actually goes to an arrow from here to here. See, we have an arrow between these two chunks, when before, notice there wasn't an arrow between this guy and this guy. So merging these together actually created a relationship going backwards to that one, which is merged with this one, which we can see right here. So the arrows pretty much, if we have an arrow before in the pre-image, then we're going to have an arrow over here in the image between them. And so you can have lots of different arrows that all of a sudden, maybe there wasn't an arrow back from here to here, but in the image there will be, because there is one from here to here in one of the things that merged with that one. So kind of an idea of arrow merging. And here's some diagrams to kind of see, just specifically different things that merge to different things here. These two guys merge to that, just different parts of the diagram, or this merge to that over here. Okay. So here's a little notation now. Notice that if we have this statement and this statement, meaning that now in this particular merge, notice that one is that you have a relationship from 1 arrow to 1 2, and a relationship from 1 2 to 1. Now in that case, we write the following right here. So 1 2 double arrow both ways, 1. All right, or at least the chunk 1 and the chunk 1 2 between the two. So we actually have this situation happening. Okay, then right. Okay, and that's just talking more about what we were discussing. And let's go down here now to the next section. That'll be the next little video. Thank you for watching.